exponentials. So on Friday, you guys learned how to determine between the two of them. It wasn't a new thing, but it was just a refresher. So now that we know how to determine if it's exponential or linear, you guys are going to be able to write the equations of them. So just as a reminder, bless you, an exponential is y equals ab to the x. A is your y-intercept, and b is your growth or decay factor. Bless you. And then linear, and there's more than one form for linear that you would probably write in. If you can't read something, please let me know. It's y equals mx plus b. M is your slope. B is your y-intercept. That's one of the forms you could write in. Or you could use point slope. You probably wouldn't go directly into standard form. Remember, m is still your slope. X1 comma y1 is your point. It's any point along the line. So those are just some things to remember when we're going into writing equations of exponentials and lines. Let's go ahead and get that copied and then we'll get into our examples. Okay, so let's look at the first slide here. So first you have to determine, is the following linear, exponential, or neither? And then we'll explain. So is it linear, exponential, or neither? So look at this, Carly. Is this linear, exponential, or neither? You think it's exponential? What is it multiplying by each time if it's exponential? So 12 times 1/2 is 6. 6 times 1/2 is not 0, is it? So is it exponential? So remember, exponentials are a constant multiplication. Just remember you're going to be multiplying by a positive number each time. We don't really deal with the negative bases in this class. So you guys would never go from positive to negative. Well, you could, I guess, if the asymptotes move down. So, but that could be kind of a sign of it. But this is... you need to test it out before you say that's exactly what it is. So like I did, I just kept on trying there. Jenny, what do you think? What is it doing on the x, though? It's not just subtracting by 6. What is the x doing? So it's adding by 2 on the x each time. So it's constantly adding the same thing on the x and constantly subtracting the same thing on the y. So that's what makes it linear, because it has a constant addition and subtraction on both the x and y. So the x values add 2 each time, while the y values subtract 6. So what is my constant rate of change? What is my constant rate of change then? Katie? Be careful.
-3.
There you go. -3. So then we have to write our equation. Who wants to write the equation for this one? If it's y equals mx plus b. Hannah, I want to take a stab at it.
Y equals negative 3x plus 6.
Why did you say plus 6 for your y-intercept?
Because when x is 0, y is 6.
Whenever your x is 0, you have your y-intercept. So when x is 0, you have your y-intercept. Very good. Questions on the first one? So even if a problem doesn't ask you if it's linear, exponential, or neither, bless you, you should always be thinking that question. And as we add more functions, you're going to be asking that question more. You'll have 4 functions going into the EOC. So you'll ask yourself, which one of these functions is it? How do I write that equation? All right. Morgan, linear, exponential, or neither for that second example on the slide? Why? You're multiplying by half. As x increases by 1, because remember the x's have to be increasing by 1, you are multiplying by 1/2 every single time. And each one is getting to the next one perfectly fine. So you are correct. It's exponential. So as x increases by 1, you multiply the y values by 1/2. Kaylin, is this exponential growth or exponential decay? Decay, why?
Because it's less than 1.
Because it's less than 1, but you're missing the other half of that.
More than 0.
More than 0, because we don't want it to get negative. So our decay factor is 1/2. So remember to write the equation, it's y equals ab to the x power. So Spencer, what is my equation, my exponential equation then? Remember, a is your y-intercept and b is your growth or decay factor. So what is your y-intercept?
Y equals 24 times 1/2.
You're missing 1/2 to the x power. So make sure you say it's to the x power. So y is 24, your y-intercept, Spencer. When x is 0, which means you haven't moved up or left or right any, so you're staying on that y-axis there. So x equals 0, then it is the y-intercept. All right, questions so far? Go ahead and get that copied then. So the change in height of the ball from one bounce to the next, if the ball is dropped from a height of 8 feet and the ball bounces 75% of its previous height with each bounce, is this linear, exponential, or neither? Is this linear, exponential, or neither? Yeah.
Exponential.
It's exponential. Why do you think it's exponential?
Because it's 75% of each bounce.
So you are going to be multiplying. So you will multiply by 75% each time. So we'll have a decay factor here. Olivia, what would my decay factor be? If it's multiplying by 75% each time, how do you write that as a decay factor? Be 3/4 or 0.75, yes. You have to change it to a decimal. So either one of those is completely fine. We just can't keep it as a percentage. So, Jillian, bless you. What is my equation?
Y equals 8,
Good.
and then in parentheses 0.75.
Yep. So, dropped from a height of 8 feet, so this is what it starts at. And is multiplied by 75%. So we got those pieces from there. Before we do the next one, what do you notice about this table?
It's not exponential because it's not going by one of the x values, and then it's not linear because they're not adding as approximate.
Let's also look at one more thing before we decide it's not linear or exponential. What do you notice about this table? Avery.
It keeps like going back and forth from negative.
It's not going from least to greatest, is it? So let's reorder this table so it's going from least to greatest, because I think it's easier to see things if it's ordered from least to greatest. So this is x and f of x. So my lowest number is -8, which goes with -11. Then -4, which goes with -2. Then 0, which goes with -5. -8, you said? Okay. Thank you. And thank you for telling me sooner than later. 0 goes with -5, 4 goes with -2, and 8 goes with 1. So I just reordered it so the x values are least to greatest. You guys see that? It makes it way easier to tell things. So how is the x increasing? Is it increasing by the same amount each time? It's increasing by what? 4 each time. So let's see if our f of x values are doing the same thing. Kelly, what do you see the f of x values are doing? -11 to -8 is how many? -11 to -8 is how many? 3. How about -8 to -5?
3.
Good. How about -5 to -2?
3.
How about -2 to -2 to 1?
1.
Be careful.
Oh, no, that's 3.
That is 3, 2. Yeah, because we skip over that 0, right? So do we have a constant rate of change here? So what is this? Linear. It's a constant rate of change. And what is that constant rate of change? Jacqueline, what is my constant rate of change on this one? Not just 3. Be careful. Remember, it's an y over x. 3/4. So very good. So we have a constant rate of change. So as x increases by 4, y increases by 3/4. I mean by 3, sorry. So the rate of change is constant at 3/4. Okay, Jenny, what's my y equals mx plus b equation?
Y equals 3/4
Plus -5, so I'm going to put -5. That's fine if you do plus -5. It's the same thing. So we do -5 because when x is 0, you have your y-intercept. All right, what questions do you guys have about either of those two before we look at some graphs real quick? All right then. For each representation of a function, decide if the function is linear, exponential, or neither, and explain your reasoning. If it is linear or exponential, you must write the equation. So Iris, is A linear, exponential, or neither? It's exponential, and why? It's a J-shaped curve, right? So is this exponential growth or decay? Growth, good. So what I would do is I would find 2 or 3 points on your graph and make a table with them so you can determine what your growth or decay factor is in this case. You know it has to be y equals ab to the x. So Madison, what is my exponential function here? Yep. So you can see here as x increases by 1, this is multiplying by 3 each time. You can see on the graph that your y-intercept is where it's crossing the y-axis at, which is at 0, 2. Okay, Sarah, that second one on there, linear, exponential, or neither?
Linear.
And why would you say it's linear? It's a straight line. Definition of a line is it's straight, but we like to overemphasize the fact that the line must be straight, right? So it's a straight line. Okay, Vivian.
Y equals 3x minus 4.
Good. You go up 3, right 1. So that's a slope of 3. Good. And as she said, the y-intercept is at 4. You cross over at 4. What questions do you guys have there? I think we only have 2 more slides, so we're getting there. We doing okay? Any questions so far? All right, then let's get through these last few examples here. And then you guys can work on homework. And everybody does have the review for the test? Nobody lost it or anything? Okay, please let me know because I would like you to have it, today if you don't have it. All right. For each representation of a function, decide if the function is linear, exponential, or neither. Explain your reasoning. If it is linear or exponential, write the equation of the function. Lee spends $25 each week to pay for his subway pass. Lee has $300 to spend. Alex, linear, exponential, or neither? It is linear. And why is it linear? The key thing in there is it's adding, right? Or he's not adding it, he's spending it, so it would be... There you go. But still, addition subtraction is linear, so subtracting $25 each week. It's constant. So the rate of change is constant. Darius, what's my equation? What'd you say? 25 what, though? No, I mean, what goes after 25? And then what'd you have at the end? Okay, there's a little things wrong with this. You did a great job. I love that you chose 25 as your slope and 300 as your y-intercept. Those are amazing. So we just have some little things we need to tweak here. So let's tweak a few of them. Jenny, what's one thing?
25 needs to be negative.
He's spending $25, so it needs to be negative, okay? So you did a great job of making 25 your slope. You just need to make it negative because he's spending it. Kelly?
It should be plus 300.
Perfect. It should be plus 300. Again, I love that 300 was your y-intercept, but because he has $300 in his pocket, it's positive. It's not negative. This is not in that debt. So that would be your equation. Very good. Okay, Joe owes his brother $50. He has promised half of what he owes each week until his debt is paid off. Alb, linear, exponential, or neither? So he's subtracting half of something each week. If you're taking half of something, what are you doing? What are you doing if you're taking half of something? What operation is that? If you take half of something, Alb.
Divide.
You're dividing by 2. So it's multiplication of 1/2. So because you multiply by 1/2 each week, month, or is it week? Each week? Okay, Alexis, give me my equation. When you're ready, you can keep writing. Very good. So he starts with a $50 his brother owes, and his decay factor is 1/2. Okay, Tim's dog, I think is what it's supposed to say, has fleas. On the first day, there is 1 flea on the dog. On the day 2, the fleas have doubled. On day 3, the fleas have tripled. Linear, exponential, or neither? Jenny? Exponential, so are you multiplying by the same number each time? No, so it's not exponential, and are we adding the same number each time? So this is neither because you're not adding or multiplying the same number each time. Okay, we have one more slide, and then you guys get your homework. All right. For that C there, is that linear, exponential, or neither? Kaylin, linear, exponential, or neither? Neither, why? Not a line or J shape, right? Very good. So you don't have to write an equation because you don't know how to write this equation yet. This is a parabola, which is a quadratic function. You will learn that second semester. Probably be doing that about the time I come back from maternity leave, actually.
Are you gonna be gone all semester?
I'll be gone some point in February, middle of February to the beginning and middle of April, so just 2 months. Plus you guys have spring break in there, so probably about 7 weeks of your class time. Okay, linear, exponential, or neither for the last one there. Madison, linear, exponential, or neither?
Exponential.
And why is that? Backwards, J curve. So what does that mean? It's exponential growth or decay, Madison? I put back around. You are right, it's decay. Okay, so we put some points on a table to figure out what we're multiplying by. 0, 8, 1, 4, 2, 2. Morgan, give me the equation. Perfect, to the x power. Good. So you are multiplying by half each time. It should be a number between 0 and 1 since we are decaying. All right. We are done. Any questions?